From here to the stars. I am your host, Stephen Euin Cobb. Our guest today is Dr. Joel Mozer. He is a highly accomplished space scientist and engineer who served as the United States Space Force Director of Science, Technology, and Research. He holds a PhD in physics and has over 30 years of experience in space science, engineering, and management. Dr. Mozer previously worked at the Air Force Research Laboratory, where he held various leadership roles, including Chief Experimentalist and Chief Scientist of Air Force Space Command. He is a member of several professional organizations, including the American Institute of Aeronautics and Astronautics, the American Geophysical Union, and the American Meteorological Society. Thank you, Doctor, for taking the time for this interview.
Thank you, and I appreciate the opportunity to talk with you today, so thanks very much.
Okay, you're welcome. In 2019, at the IRG Symposium in Wichita, Kansas, you gave a talk with the title, Perspectives from the U.S. Air Force. What were some of those perspectives you spoke about?
Yeah, so we'll get around to my evolution and how I got to this point, but at that time I was the Chief Scientist of Air Force Space Command, which is here in Colorado Springs, Colorado. And I had only been the chief scientist for a little more than a year in that role. And one of the things that I discovered when I came to that position was there's not a lot of very far strategic foresight going on. People thinking, what's the technology taking us to? Where could we be in a decade or two or three in the future, and what preparations are we doing for that? So a lot of my work there at Air Force Space Command was to try to uncover some of those issues, some long-term, what could change from what we see today. And at the time we were very worried about things like China and the South China Sea and geopolitical conflicts, but what are the things that could change? What happens if we start colonizing the moon or Mars or eventually interstellar travel? What's the role of at the time Air Force Space Command in a world where we have those kind of things happening? Because science a lot of times takes time, and you need to invest in it early in order to be prepared for those kind of futures. So that talk in Wichita, Kansas, was about that and the perspectives of thinking long term and adding strategic foresight. We had just finished a document called the Future of Space 2060, where we looked out to the year 2060 and imagined what the range of possibilities could be and what the role of Air Force space would be in those scenarios. And so that was the basis of the talk that I gave there.
Okay. You made a post on LinkedIn 4 years ago in which you declared, quote, "The U.S. Space Force rescue team is standing by. These folks are ready to make sure that American astronauts Bob Behnken and Doug Hurley are safe," unquote. I don't want to sound specious, but is one of the goals of the U.S. Space Force to provide a space ambulance and a team of space paramedics?
That's an excellent question, actually. And one of the things that we looked at in this Future of Space 2060, and I'll get back to that in a second, but I think one thing that people don't realize is that there is a human space flight component to what was Air Force Space Operations and now the Space Force. You'll hear people saying, the Space Force doesn't send humans anywhere in space. Although we've had Air Force and Space Force officers in space because they get transitioned to NASA, but they're not necessarily doing military Department of Defense work. But there is a mission that is given to us by national authorities when there are humans aboard a space flight launch. We do the rescue if needed. So we have teams of people trained to do space flight rescue in case something goes bad during a launch, say off the coast of Florida. And that event was the first return to space on an American flight. I wanted to point out there was an Air Force mission for spaceflight. Now, I said when we looked at the year 2060 that might change. That's a really good example of one of the conditions that we need to think about today to understand what we need to invest in the future. So if, for example, in the year 2060, there were a lot of people living and working in space, and say cislunar space, then we would probably need to expand the Department of Defense role of humans in space just to be able to protect it. That's one of those things that we can't forget about. Today we don't send Space Force people to do Space Force missions in space, but in the future we might, and we might need to have a role or a mission there. Those are the kind of thoughts that I'm trying to instill into the current leadership and workforce in the Space Force, so that we don't find ourselves flat-footed when the day comes.
Mm-hmm. Okay. In that same post, you mentioned that Patrick Air Force Base was soon to become Patrick Space Force Base. How much of what was formerly part of other branches of the military have been handed over to build out the U.S. Space Force?
Yeah, that's a great question. So, Space Force was created in December 2019. So we're celebrating our 5-year anniversary, 5-year birthday now. And a lot of changes happened. The Department of Defense and mostly the United States Air Force had been flying satellites and building constellations to do missions like communications and missile warning and space situational awareness for a long time. But when we stood up the Space Force, the idea, the directions we got from Congress were to consolidate a lot of the military activity that even the other services were doing into the Space Force. So, the Navy is probably the biggest user of satellite communications, because they have to communicate with their ships at sea. So the Navy had a fairly significant space component, and they do quite a bit of research at the Naval Research Laboratory in space physics and space capabilities. The Army has space capability for over-horizon communications and other things. So components that of the other services doing space were largely consolidated into the Space Force. And so while at the time, most of the early military members, Space Force Guardians, came from the Air Force, we also had people that transferred from the Army and the Navy and Marines and became Space Force Guardians as well. So some of that process is still going on. For example, I mentioned the Naval Research Lab does space research, and they still do under the auspices of the Navy today. But for a number of reasons, one of them is that they're doing it specifically for their service. They have their own independent needs for the Navy to do research. So they were allowed to keep their people working in doing research in space physics and related fields. And I think that's all for the good. It's they still can be called upon to action from the Space Force if we have a need for their particular expertise. And they have a lot of expertise in things like space robotics and space or solar imaging and coronagraphs. We can draw upon that just as we would from our own Space Force research folks. That process is still underway, where we're moving units and pieces and parts from throughout the Department of Defense into the Space Force, but it's largely complete at this point.
Oh, okay. Let's see. As a director of science, technology, and research for the U.S. Space Force, what were your top priorities for advancing space capabilities and ensuring national security in the space domain?
Yeah, and that really was, let me back up a little bit and talk about how that position was created. So the Air Force, before the Space Force was created in 2019, didn't really have a position like that. There was the chief scientist of the Air Force, which is an important position, but mostly advises senior leadership on science and technology. when we created the position of Director of Science, Technology, and Research for the Space Force, the real customer target audience for that was the research laboratories, and trying to consolidate all of the different demand signals that Headquarters Space Force had in the area of technology and science, and provide them back to the research community in terms of a set of priorities, so that they would know, what to spend their precious science and technology money on. Because we don't get unlimited amounts of money to invest in science and technology. So you really want to go after the most important ones, and that was really part of the reason for the long-term strategic foresight. Is you want to make sure not only are you worried about known technology gaps today, things that your acquisition programs have as problems that they can't solve today. You also need to have a mid and a far term look, so that you're putting the seeds down for things that will become sort of the known unknowns in the future. And then a little bit of your funding really needs to be put against the unknown unknowns, the things that could potentially surprise us in the future. And that's pretty exciting research, because it involves non-traditional things like biology and psychology and quantum physics, things that aren't necessarily here today in terms of space importance or importance to the Space Force, but could be in the future. And if we don't pay attention to them now, and our adversaries, for example, do, we could be surprised by some developments in the future. So you asked what the most important priorities were. There were priorities in each of those three buckets, sort of the near-term needs, and we won't get into too many of those, but basically, if a program of record has a gap, we would put some investment into trying to figure out how to close that technology gap. In the midterm, we know what our threats are going to be, now and into the future, maybe 5-10 years from now, and we need to design a force that can respond to those threats that we can see coming, and the opportunities to have a more secure system. So a lot of those priorities were around the resilience of our space systems, making them robust. As more and more space gets pulled into geopolitical conflict, we need to be able to protect those assets and ensure that they can operate through, even in the time of fog of war. So that was a lot of the midterm kind of priorities and research. In the long term, was just what I said. Where do we want to put some money to avoid technology and strategic surprise in the future? So had sort of an array of those kind of priorities.
Okay. The U.S. Space Force was established, as you said, in 2019. What is the significance of establishing the Space Force as a separate military branch, and how do you see it contributing to U.S. space security in the future?
Yeah, that's a great question, and a topic of debate even today, whether or not the Space Force should be independent. As I said earlier, the Air Force has been doing space work since the beginning of the space age, and so have the other services. Sputnik was the first satellite launched by the Soviet Union, but the second Explorer 1 was a DoD satellite looking at some basic research in space. So we've been involved all along throughout the space race. Part of the reason for creating the United States Space Force in 2019 was a realization that we had gone beyond a tipping point in sort of the importance and necessity of space. Space is really integral to all of our lives, everything from ordering an Uber to communicating on your cell phone these days has got a space component into it. So those, just like any other national infrastructure capability, needs to be protected, so that just argues for more attention to be paid for that. But also, if space ever does extend to, or warfare ever does extend to space, we need to be prepared with the capability to operate in and through space. And that was the language that was provided to create the Space Force. And what it really did is it separated what was largely in the Air Force but other services into its own military service as part of the Department of the Air Force, so that investments in space could be more carefully managed and tracked, and that the culture of operating in space would be captured and nurtured in the same way that Army troops their culture is to protect the ground, and Navy the sea, and now we have the Space Force who come to work every day thinking about how to protect and defend space assets. So there's that's all on the positive side. On the negative side, the questions are: is there enough resources to create another military branch? Is that just going to create more overhead and bureaucracy, or is it going to cost more? Are we going to spend too much time nurturing a new service and coming up with things like the service song and the flag and the uniform, all those things that kind of detract from actually doing the mission? Is this the time to do that? So there were plenty of detractors who made those kind of arguments. And then there's sort of a third set of arguments that is driving a conversation even today about how much of the Space Force should be part of national strategy and grand strategy, not just from a military perspective, but around all other instruments of military power, the diplomatic, the informational, and the economic components. So some would argue that we don't need a Space Force, we need a space service that maybe combines some of the mission of what NASA does today, some of the mission of what the Department of Defense does, and then maybe some mission around commercial space, and have something that's bigger that can drive national effort. So that conversation is going on too. So long answer to your simple question, but
Long answers. Some people don't like long answers, but I like long answers because you get more insight into what's really going on and how a better understanding of the topic. Anti-satellite weapons pose a serious threat to the stability and security of space. How do you see this threat, and what can be done to deter their use and protect space assets from attack?
yeah, that really is the core question these days. Technology has come to the point where our assets in space can be held at risk by anti-satellite weapons, and that those could be ground-based. Think laser dazzling of our satellites, or reversible effects that could provide outages of our services provided from space, but only for a temporary time. Up to the other end of the spectrum is a high altitude nuclear detonation. If a rogue nation set off a nuke in low Earth orbit, could wipe out all of our satellites potentially, and that's irreversible and fairly dramatic. And there's a spectrum of threats between those two things. In the technology is developing to be able to do those kind of things in new and frightful ways. Technology is spreading around the world, so more and more nation states or actors have access to those kind of weapons somewhere on that spectrum. So it's even more important than ever before that the United States have the ability to protect our systems. And one of the big shifts that I alluded to earlier is, early on in the space age, we would build, for example, geostationary satellites that were big, expensive assets that we would put into orbit, thinking that they were pretty much in not vulnerable to attack because they're so high and it's so costly to access geosynchronous space. And to make things worse, we would even aggregate more and more missions onto a single satellite, a single bird, because launch was so expensive. You could spend $150 million on a launch. So you might as well put as much capability on a single satellite as you could to get the biggest bang for the buck. Well, those are not the things you would want to do if your satellite could be held at risk by an anti-satellite weapon of any sort. So a lot of the work that's been going on for the last decade in the Space Force and the Air Force before that is figuring out how to make our systems more resilient against anti-satellite weapons. To maybe instead of having $100 billion asset, let's have 1,000 smaller assets that could be replenished and don't provide as much target surface area as a single high value asset. Mm-hmm. So that's where a lot of the work and the thinking around anti-satellite weapons. And you mentioned the word deterrence, and that's our ultimate goal is to deter warfare from occurring in space. And that's a huge challenge and something that's on the mind of Space Force leadership all the time. Is we want space to be open and accessible for commercial development and free trade and open access. We don't want to create situations where space is a dangerous, hostile place. So we want to deter that kind of development as much as possible. And that's where things like norms of behavior and things like the Artemis Accords, where we get our allies and partners to talk about how we can peacefully go back to the moon together. Those are very important things because we don't want space to become a hostile, weaponized environment. That wouldn't be good for anybody.
Space junk is a growing concern, from old dead satellites to loose nuts and bolts to little flecks of paint. All these items can cause damage to anything in orbit that they hit. Can you describe projects you've worked on to address the problem of space junk?
Yeah, and if you have a solution to the space junk problem, we're all ears. It's a real problem.
Okay.
Just a growing number of things in orbit that we have to worry about and need to dispose of. So from my perspective, a lot of the work that we've done is figuring out how to ensure that our satellites that we launch into space are safely deorbited or de-energized so they don't explode and make lots of small shrapnel pieces flying around at high speed just because of their end-of-life destruction. So a lot of the solution to space junk is to not create it in the first place and to make sure that if you put something up, you have a plan to bring it back down. Because it's very hard, as you say, some of these things are nuts and bolts flying around at orbital velocities that can cause a lot of damage. Well, how do you catch those things and bring them back? And there's been a lot of ideas and techniques that have been tried and proposed to deal with it. But so far, I don't think we have the silver bullet for how to deal with the things that are there today. The best we can do right now today is to make sure we don't make the problem worse by sending things up that are going to collide. A lot of the work that I did throughout my career at Air Force Research Lab was around space situational awareness. So just understanding where objects are in their orbit with fine enough precision that you can predict when a conjunction or a potential collision would happen. And then, if there is a conjunction with a relatively high probability identified, that there's the ability to maneuver one or both of the satellites to avoid a collision. I was just reading the International Space Station just had another maneuver recently in the last couple of weeks to avoid a collision. So fortunately, we have the ability to do that, and we have to be vigilant in watching for those things in orbit and predicting, days in advance when something's going to happen. Because the earlier you identify the potential collision, the less energy it takes to avoid it. If you identify it at the last second, it's a expensive, desperate fix. But if you can identify it a few days early, you can do that. And that's one of the missions of the United States Space Force is to do some of those conjunction analyses and to monitor things to make sure that the collisions don't happen.
Mm-hmm.
Big problem.
Years ago, I don't have this written down as a question, but years ago, I used to do a podcast for 10 years. It's called The Future New. And on there, I did an essay because I'd come across a website that was showing space junk. It was a model of the Earth, and you could zoom in different locations and stuff. And it showed this cloud of space junk. And my essay was mostly about a critique of they have, satellites and nuts and bolts and stuff. The dots they were using to display them were like 50 miles wide.
Yeah.
And so it made the cloud look much worse than it really is. How bad is it? Just how bad is space junk?
Yeah, well, it's a real problem because we do have conjunctions on a regular basis that need to be mitigated in some way. Mm-hmm. But you're right, space is very large. In reality, two mosquitoes flying around the Astrodome are probably have the sort of collision probabilities that two pieces of random junk in space have. Space is vast, and we're talking about huge volumes, but we are talking about tens and maybe hundreds of thousands of objects traveling at orbital velocities. So when you have a bad day, it's a really bad day. So it's not something that we can ignore. And the fact that it's a growing problem is not good at all. We can imagine runaway breakdown events where a few big collisions can lead to smaller collisions and pretty much deny anybody access to space. And that's the real worry, is if particularly low Earth orbit gets to be so cluttered that we can't even launch through that mess, then that's bad for all of humanity. It's going to limit our ability to do anything in space. So it's a relatively low probability problem right now, although the consequences are high. So it's something that we need to pay attention to.
Okay. International collaboration is often beneficial in space. How is the U.S. Space Force working with international partners to address common challenges in space, such as space debris, space traffic management, and international norms you mentioned of behavior in space?
Yeah, so all of those things, we're working with our with international partners. So a lot of things that I have to say about that, though, this business of looking towards the long term, when maybe there might be orders of magnitude higher value to the space economy, or orders of magnitude more people in space in the future. It's really important that we bring in our partners and allies and international friends to think through what the world will be like in those futures. And so a lot of what I led was bringing folks together like that to do the strategic foresight, to think through the far distant future and what the scenarios might be. Because technology is growing at an exponential rate. We're seeing new technologies occur faster than any time in history, and they're spreading around the world faster than any time in history. So it's really become an international endeavor to make sure that we stay ahead of that, and that things don't get out of control in a way that we don't have the ability to reverse or stop, but to take advantage of these. So one of the successes I had when I was the chief scientist of the Space Force was establishing what we called Space Strategic Technology Institutes, SSTIs. And the idea there was to get academic institutions together, form consortiums around a few problems that we have in the Space Force. So, for example, Um, Beyond geosynchronous operations was one of that. How do you operate in cislunar space and do things? Or advanced power and propulsion. If we ever wanted to think about nuclear power and propulsion in space, there's probably some fundamental research that needs to be done before that. So we would establish these SSTIs around those topics. And then the idea was to tie them to entrepreneurs and industry to commercialize those ideas so that eventually the Space Force and other parts of government could buy that technology back. So we're in the process of standing up 5 of those SSTIs. In even more than that, to get back to your question about international partners, is to create international space strategic technology institutes where we involve our partners and allies that have technologies that could really relate to the future of space, in collaborate with them now on those technologies. So we're still we're sort of starting with our Five Eyes partners to bring in some of that, but we're expanding because the number of spacefaring nations just continues to grow. And there's a lot of very interesting technology being developed that we would like to incorporate into what we do and how we plan for the future. Mm-hmm. So from a research perspective, that's very encouraging that we're pulling in our international partners.
Mm-hmm. Oh, and for the few people who are not familiar with the Five Eyes, if you would list the countries.
So that's just our closest allies that we share the most information with. So it's the U.S., UK, Canada, Australia, and New Zealand are in the so-called Five Eyes. It's sort of from a national security perspective, it's the easiest group when you're talking about the Department of Defense to communicate with. But that's not to say that we don't also have lots of other friends and partners around the world that we will eventually incorporate into these international space strategic technology institutes as well.
Okay. The Artemis program aims to return humans to the moon. What are the potential implications of the Artemis program, not just for human space exploration, but also for science, technology development, and international cooperation in space?
So there's lots, and I referred earlier to this report that we wrote about the year 2060, Future Space 2060, which I encourage your folks, you can Google it and download it. But in there, we looked at sort of 3 principal uncertainties about the future, things that we don't know how they're going to evolve. One of them is leadership in space. Is there going to be norms and behaviors established by any particular geopolitical event, and how is that going to evolve? The second thing that we looked at was the economy of space. Today, the space economy is somewhere around $500 billion a year, depending on how you account. And some people would say it's going to grow to $50 trillion by that period in time. So that's going to change our outlook as well. But the third one is humans in space. Today, when I first started giving this talk, there were 6 people that lived and worked in space. They were all in the International Space Station, but now we have a Chinese space station. We have private space missions. So I forget what the record is up to, but we've had more than a dozen folks in low Earth orbit at a given time, just in recent times. If that grew to, say, thousands or tens of thousands of people in space, for example, living and working on the moon, that's going to bring, sad to say that any time that humans have colonized or moved into a new domain, conflict will arise. That's just part of human nature. So there will be a role for not only national security around the Department of Defense kind of activities, but also constabulary needs, so things like space piracy and criminal trafficking in space might become a thing. I'm hoping it doesn't, but it might. But we need to be prepared for those things. So from a security perspective, I think we just need to stay at least half a step, if not a full step ahead of the development of those things to make sure that we don't get caught flat-footed. So things like the Artemis Accords, and there's lots of activity around the Committee for Peaceful Uses of Outer Space and through the United Nations, and we need to strive for the best that humans can provide in the future, but we need to be prepared for securing the future of space on the moon and Mars and beyond. So now's the time to look forward to that.
Okay.
Not sure if that answers your question, but that's an answer.
I thought it was pretty good. U.S. China competition is a defining feature of the 21st century. How do you address the current state of how do you assess the current state of U.S. China competition in space? And what steps should the U.S. take to maintain its competitive advantage in this domain?
Yeah, of course, that's a giant question you just asked, and we are in an era where we have a technological peer. A lot of the things that China is doing today are things that the United States and our allies have done in the past. For example, putting up a space station. But one thing that is concerning is that, and this is sort of just the way things have evolved in cislunar space. In the United States, we have sort of a moral ambition to go back to the moon and to colonize Mars because we like exploration and expanding our domain. But in China today, there are very definite plans that come from the leadership on, for example, developing the cislunar economy, developing the moon, and creating the resource extraction capabilities to mine things like helium-3 if that becomes a thing, or to find water on the moon that could be leveraged for rocket fuel to go beyond the moon, and to create an economy in cislunar space that's vibrant and strong. And there are stated goals from China to do just that, to become the technological leader in cislunar space in the next decade or so. In the U.S., we're a little less concrete and sequential about that, shall I say. We have sort of an oscillation between going to the moon and not going to the moon, and maybe going to Mars, or maybe going to the asteroid. Kind of interesting that sometimes that happens on a 4-year cycle, kind of synchronized with our presidential administration sometimes. Mm-hmm. But we have less of a government directive that says we're doing this kind of expansion and development. So I'll leave it for an exercise to your viewers. One could argue that there's an advantage to each of those approaches, and disadvantages too. Some of the advantages are, if you have a clear goal, there's a much better chance that you're going to achieve that goal. On the other hand, there's some advantage to what I'll call chaos in terms of where we're headed with those kind of big ambitions, because we may be diverted into other areas that are even more important than specifically, say, mining helium-3 on the moon. Maybe there's something else that we find to be more fruitful or more economically advantageous, because we're more open to other possibilities. So that's how I kind of see some people would call it the space race today. There's sort of a very focused, directed set of goals on the side of China. There's a little bit more diffuse, but a lot of momentum behind them. Set of activities. I mean, just look at what's happened in commercial space just in the recent years. Lots of great developments that have been happening there. Had that been a government-directed program, we probably wouldn't be nearly as far along in things like Starship as we are today. So it's kind of a difference in philosophy and in outlook and how you might go forward. But it's there, and how the future will turn out was to be determined, I think,
Always. Yeah.
by definition.
Yeah. Let's see. You mentioned private companies. Private companies such as SpaceX are making significant strides in space technology and exploration. How do you see these companies supporting U.S. national security objectives in space? And how is the U.S. Space Force engaging with the commercial space sector?
Yeah, they're going to contribute tremendously and already have. Things like the commercial launch has dropped in cost precipitously because of things like reusable launch vehicles and things that are being developed. The smaller launch vehicles, smaller payloads and capabilities, all being driven by commercial interest, have been all to the advantage of the, the Space Force and to the Department of Defense. And we are partnering. We are looking to drive that industrial base in ways that not only benefit us as the Department of Defense, but also to benefit the nation. Is just having that strong economic base, because that's just as important to national security as a strong military. For specifically SpaceX and Starship, we have a program to potentially use the Starship to get cargo moved from one point to another on the surface of the Earth for things like disaster relief, or something where you need to get a large amount of material from one point to another in matter of minutes. Something like that could be used. So we are partnering with the commercial development and encouraging it wherever it goes, because we know that rising water supports all boats, or whatever the space analogy to that is. We want that technology to move forward and ensure we have a strong industrial base. And there is a commercial space strategy that the Space Force has put out that outlines how we're doing that. I'd say that's still developing and will probably change over time as we learn better how to take advantage of the tremendous leaps and bounds of commercial technology. One of the challenges we do have as the Department of Defense is, we have a lot of infrastructure in place today. So imagine, some of the missions that we do, like position, navigation, and timing with our GPS constellations, which is a Space Force constellation, by the way. Our satellite communications, our missile warning, space situational awareness. That represents a lot of investment that's gone in to create those things, and a lot of infrastructure that just can't turn on a dime. We can't just take some new commercial idea and implement it immediately, even if it is a fantastic idea and could give us more capability. So there is some degree of lag and architecture that needs to go on. If there is a new idea that comes from commercial entity on how to do a mission better, we need to figure out what's the path to go from the way we have it set up today to using that new technology. And sometimes that takes a little time. One of our challenges is figuring out how to become more agile and more forward-leaning and timely in those kind of situations, so that we can take advantage of technology, which again argues for what I mentioned way up front, is very robust long-term strategic foresight. So you can at least anticipate what's coming before it gets here, and hopefully it made some good strategy decisions to take advantage of that.
Okay. Artificial intelligence and machine learning are transforming many fields. How do you envision their role in enhancing space control, situational awareness, and decision making in space operations? What are some of the potential challenges in integrating these technologies?
Yeah, and then the challenges are what I just mentioned. Basically, is we have infrastructure that's built around sometimes fairly basic and aging technology. For example, our operational floors don't necessarily have the latest and greatest racks of GPUs that could do the AI that's needed to do operations. So we have to get there. I'll give you a specific example. And, you know, all those things you mentioned, like space control and doing operations in space, we absolutely need to look at how artificial intelligence can be incorporated in those things, because we know our adversaries will do that, and we need to be able to close the so-called OODA loop, the observe, orient, decide, act loop. Theory of warfare is you got to do that faster than your competitor. But let me give you one specific example. This is sort of related to the work I've done in the Space Force and artificial intelligence, and it is this this idea of strategic foresight. So if you imagine that, strategic foresight is looking ahead in the future and trying to imagine as many scenarios, realistic scenarios as possible, and to challenge your assumptions about the future, and to think as broadly as possible so that you're not surprised by when the future arrives. There's a role for artificial intelligence to help humans do that. That is almost a pure effort of creativity to think about what the future could be. Now you have to inject some realism in there. You need to discount things that are physically impossible to do. Although sometimes your idea of what's physically impossible might change over time. So you need to question some of those things. But you need to be creative and thinking about what could happen. So some of the research that I've been doing since I retired as the chief scientist of the Space Force is around what kind of human-machine teaming could be done, taking a human or a group of humans, coupling them with some artificial intelligence, for example, large language models or whatnot, and trying to enhance the ability of humans to think creatively about the future using artificial intelligence. It's kind of like freestyle chess, which is, you take good but not great chess players and you couple them with artificial intelligence that can play chess. The combination of the human and the machine can beat just about any AI or grandmaster chess person in existence. Same with strategic foresight. If you can couple the AI with the humans and expand the thinking of either one of them in a way that allows us to think more creatively about the future and what the path to get from here to that future might be. So that's one example in my field where we're actively pulling in AI. And you can imagine in other sort of more operational domains of the Space Force, like space situational awareness, we have telescopes around the world taking observations of every dot in the sky and how it's moving and creating catalogs of those. It's hard for humans alone to identify patterns of behavior or things like that might be happening in those space objects, some of which might be nefarious. So artificial intelligence is sort of a natural to apply to those kind of data sets. In each mission area that the Space Force has, I would say there is work going on. How do you incorporate AI into this mission to make it stronger, faster, and to get inside the OODA loop of any competitor that we might have?
Cyber attacks are a growing threat in all domains, including space. How would you respond to a major cyber attack targeting critical U.S. space assets such as communication satellites or GPS navigation system?
I'd panic. What would you do?
Well, hopefully you've got more assets than I've got.
Yeah, no, cyber operations, cybersecurity is a huge worry for the Space Force. We have operational floors of people that are watching for those kind of things. I think in the future, as we become increasingly more dependent on space assets for all that we do, we will just have to be vigilant in increasing our cyber security posture, and that's inter-satellite links, space-to-ground links, all those things. And I'm pretty jazzed about the potential of things like quantum secure communications and new technologies for securing those things. Those are not a matter of nicety; they're a matter of absolute necessity. If we're going to survive into the future in a quantum-enabled world, we need to have the infrastructure set up. We need to start investing in that today, so that this problem of not being agile to new technologies doesn't become a thing. For example, if quantum computers become available widely that can break our encryption systems, that'll completely destroy big swaths of our ability to operate. So we need to be in a position to be able to employ the latest quantum secured encryptions and other technologies that allow us to protect for that. So short answer is we have lots of Space Force Guardians watching the problem today, and we're thinking about how to incorporate the next generation of cybersecurity in the future.
Okay. The space environment can be extremely harsh for spacecraft. What is your understanding of the space environment, including factors like radiation, micrometeoroids, and extreme temperatures? How do these factors influence spacecraft design and mission planning?
So this is actually my field. So space weather is what I spent most of my career at the Air Force Research Laboratory doing, and it's probably an area that's not given enough attention even today, but it is a very important area. So my specific small contributions to the field of space weather have been around solar physics. I spent a period of time, several years in southern New Mexico at the National Solar Observatory on Sacramento Peak, doing what your mother always told you not to do, staring at the sun all day, watching for emissions and coronal mass ejections and storms. There's an anecdote, I think it's between Apollo 15 and 16, I may have the numbers wrong, but in 1972, there was a coronal mass ejection that, had there been Apollo astronauts on the moon or in lunar orbit at that time, they would have likely received lethal doses of radiation from that, or near lethal dosage from that geomagnetic storm. So as we talk about expanding humans into space, that's a critical area that we need to keep our eye on. That ball is radiation storms do happen, and our pink fleshy cells don't react too well with those things. But even today, there's several pretty strong effects due to space weather on our operations. A solar storm can create ultraviolet radiation that essentially expands the upper atmosphere, extends it out further into low Earth orbit, and can create more drag on satellites. So during a big storm, our satellites can start changing orbit due to that drag, and we can lose track of them. And back to the collision problem, that's not a good thing. So that's one effect. During solar geomagnetic storms, we can have bit flips on our satellites that can just interact with the electronics and cause them to go haywire. Those things happen all the time. We have to be prepared for them. We engineer around them as much as possible. But from a Department of Defense perspective, those kind of effects, whether it's drag or communications outages or bit flips on your satellites, one thing that we have to do almost immediately is, if we detect an anomaly on a satellite, we need to determine, was it a space weather event? Was it one of these mechanisms that can mess with your system? Was it an engineering bug? We just designed something wrong and we blew it. Or is somebody doing nefarious activity to your satellite, back to your anti-satellite weapon thing. And not only do you need to determine that with pretty high degree of confidence, you usually have to do it pretty quickly too, if depending on which of those three things it is, you need to react. So I only see space weather and the effects of space natural phenomenon on our systems growing in importance as activity in space grows.
Okay. Yeah, when I've interviewed, I don't know, hundreds probably people that are involved in space stuff, and they always emphasize that space is a harsh environment, but I think many people that are not following space that closely, they watch TV shows and space travel is trivial.
Right.
There is no problem. It's like, everything's hunky dory, and it's like it's not really that real as far as that goes. Yeah.
That's
Um,
right. One of the high points in my career in sort of the event that got me into space physics in general was back in 2003. We launched what was called the Solar Mass Ejection Imager, and this was a satellite in low Earth orbit. It was in sun synchronous orbit um, that had some very low light imagers on them, and they could see the scattered light from um, the charged particles from a coronal mass ejection um, in the sky. So it was a lot akin to looking at a satellite cloud um, image. You could see a mass ejection, a coronal mass ejection, as it traveled from the sun out to the orbit of the Earth and even beyond. You can see it as it went off towards Mars or wherever. And that was the very first time we were even able to see these clouds of electrons and plasma that affect our system. So it was akin to if you were looking for hurricanes in the Atlantic, for example, and all you had was an anemometer at sea, you might be able to detect the hurricane if it's over the top of you, but you couldn't see it traversing the Atlantic and making landfall. So SME, the solar mass ejection imager, was really the first time we had that kind of visibility on a coronal mass ejection. And even today we're still looking at the data from that mission and how these things travel from the sun to the earth and the morphology and the dynamics of the clouds. It's fascinating research, but we're far from being able to deal with all of that natural hazard, as you say. It's not as pristine of an environment as one would like.
yeah, yeah. Are there any ongoing research efforts focused on developing new and innovative space-based sensors or imaging capabilities that could significantly enhance our understanding of the space environment or improve space situational awareness?
The short answer to that is absolutely yes. And in fact, I mentioned these Space Strategic Technology Institutes, SSTIs, earlier. One of those is around advanced remote sensing. So we're looking at things like quantum sensors and new modalities of detecting things in orbit or from space. So it will always be a wide open field to develop better ways to do that sensing um, in space weather in particular. So just for the reasons that I just said, it's hard to see these things in space coming. So new ways to look at them, new sensing capabilities and modalities are a very strong subject of research today. Um, and I think we'll see as we grow our presence in space with larger and larger proliferated constellations, we will collect more data about what the space environment's doing and do a little bit better job. We're probably, it's often said we're 20 years behind where terrestrial weather forecasting is. That's where space weather forecasting is today. Um, so we'll get there eventually, but lots of research going on in how to do that.
Okay, okay. You specialized in space control and remote sensing. In your view, what are the most critical challenges facing the U.S. in maintaining space superiority in these domains?
Well, it's we need to be able to have the foundation of space control is the space situational awareness. So understanding what's out there, what your environment is doing, what your uh, potential adversary might be doing, what the intent of satellites or objects in space might be. So we will always have um, a role to play in increasing our knowledge of what's going on in our environment that we operate. And that drives a lot of research. So even today, space situational awareness is kind of at its infancy. We're not in a position where we can accurately track every object in space with full custody all the time, anywhere around the globe. So there are gaps in our ability to do space situational awareness, which is not surprising. I think when it comes to space control, the better we get at the space situational awareness, the better we'll be able to do any of the other missions. So it's really mostly about, how is the space domain going to evolve, and what are we going to be called upon. One of the directives that Congress gave us when we stood up the Space Force was to protect U.S. assets in space, or U.S. interest in space. As those interests grow, we're going to have to figure out how to grow our ability to protect them as well. So a lot of how the space economy and space exploration and commercial space and space tourism evolve will determine how the ability to maintain space superiority will be executed. So it's something that's not an easy solution, and it won't end anytime soon. We just need to keep on top of it.
Okay. You managed a significant research and development budget as chief experimentalist of the Air Force Research Laboratory Space Vehicle Directorate. Can you share your insights into the process of prioritizing investments across various space projects?
Well, you say it was a significant investment. I would always want more, but or significant resources. So that was really around, the Space Vehicles Directorate of Air Force Research Laboratory, located at Kirtland Air Force Base in New Mexico, has a long history of flying experimental spacecraft and demonstrating new capabilities in space. And for many years, they had a fixed funding line that was for space experimentation. And so my job as chief space experimentalist was to take all the different ideas that people had, whether it was a space weather mission or a space situational awareness or a space control, or even just a new piece of hardware that needed to be tested in the space environment. People would bring those ideas, and we would try to figure out, which one has the biggest bang for the buck and the most priority. And we worked in close cooperation with the Department of Defense Space Test Program, STP, which is a pot of money that's set aside at the DoD level to do test and evaluation in space. So putting new hardware in space, flying new missions. And so we partnered with them to come up with different space experiments that were of importance. So I already mentioned one of them, the solar mass ejection imager. That was one of those space experiments that came out of Air Force Research Laboratory. There's been several others in just about any mission area that you can think of. We've flown some experiments to prove out the technology. There's some interesting work going on. It has been going on the last couple of years. Experimenting with very large solar arrays in space to do space power generation. So, it's a fairly wide ranging set of experiments. And that was, so how we did that was, my job was to take all the inputs from the scientists and engineers that had new ideas of things to do in space, and then get them talking to the users and operators that have missions that they need to accomplish in space, and try to find the common ground between the two of them where the new technology and met a need or met a potential need in the future. And the ones that popped out were the ones that got flown. And typically they would be fairly limited. They would be Class D satellites that only had a few years lifetime by design. We would typically operate them for about a year doing different things. One of the other experiments I was highly involved with was Angels, which was the automated navigation and guidance experiment for local space. It was one of the first satellites, maneuverable satellites, to do rendezvous and proximity operations in geosynchronous orbit. So it was what you would call an inspector satellite, the ability to go fly up and take pictures of another thing. It was an experiment. So what we took pictures of was the upper rocket stage that took us to orbit. We flew around it for a little more than a year, taking pictures of it and practicing how you would do that, those rendezvous and proximity operations. Those capabilities that we determined in that experiment are parts of operational satellite constellations today, like GSAP, the Geosynchronous Space Awareness Program, use that technology that we developed. So that, there's lots of cases of experiments that came out of that funding line that have made big changes. One of the next ones to launch, and it should have launched already, but being delayed by the Vulcan launch schedule, is Navigation and Technology Satellite 3, NTS 3, which is to look at precision navigation and timing capabilities to replace or to evolve the GPS constellation. So NTS-2, the previous experimental satellite around PNT, was launched in the late 70s and led to GPS. So now we're overdue to have another experiment to really push the envelope of how we do PNT in the future, including what you mentioned earlier, cybersecurity, and make sure that we can create positioning signals that are less vulnerable to jamming and things like that. So NTS3 will do that. So those are the kind of things that the chief experimentalist got to work with. Pretty exciting stuff.
Innovation often involves taking risks. How do you create an environment within your organization where calculated risk-taking and innovative thinking are encouraged and rewarded, even if some initiatives don't succeed?
Yeah, with great difficulty, actually. So, in an environment where you are working for the Department of Defense and your job is to protect and defend assets, you tend to develop a fairly risk-averse posture. You don't want to launch off on some new technology that involves some risk, and because that you are in charge of protecting against an existential threat. That if you turn your head for even a moment, bad things could happen. So the military tends to be very risk adverse, and to innovate, sometimes you have to take risks. So that's a very prescient question you ask: is how do you innovate in such a risk adverse environment? And the answer is lots of analysis, wargaming, testing out new ideas and concepts. Some of the strategic foresight that I've mentioned a couple of times to imagine what the future is, and thoroughly think through whatever innovation that you're trying to do, to understand what vulnerabilities or new threats that you might expose yourself to. You just have to do that. It's just part of the nature of the business working for the Department of Defense. And again, that's one of the factors that tends to slow us down in terms of adopting new technologies. We have to go through all of that thinking, but the real trick is balancing your risk calculus with your need to innovate calculus and coming up with a good balance so that you're not too hard over on one way or the other. And fortunately, the Space Force has an organization like the Air Force Research Laboratory, which services both the Air Force and the Space Force, that are able to test out some of these new ideas. And it's back to the experimentation that I just talked about. But even beyond that, a lot more analysis and operations research that goes on before a new technology is put to service has been thought about quite extensively.
Okay. The phrase risk averse seems key to the slowness of not just, I mean, military organizations, but also NASA. And it seems that the polar opposite of Elon Musk and other, commercial innovators, who their motto is move fast and break stuff.
Yep.
And I mean, they're not afraid to blow a rocket up because they'll learn something from it. But if you're a government, working for the government, they don't want you to mess around and blow stuff up.
Yeah. Yeah, and that what you say is absolutely true, and it's not all. It's for good reason. At some point,
Yeah, yeah.
if we were blowing up rockets at the rate that Elon Musk is using taxpayer dollars, I would have guessed there would be some blowback on that. So there, just being government stewards of taxpayers' dollars, we have to be risk adverse a little bit, just based on that. Um, and then there's the existential mission that we do, also, as I just described.
Mhm.
But that's one of the reasons we do need to be partnering closer with commercial space and commercial entities, because they can do things that we can't fundamentally do, and move the technology fairly fast. So what we have to be is, as much as we can, with our risk adverse posture, um, be willing to take on the technologies as they are proven out and demonstrated. So that's
Mhm.
where the challenge lies.
As chief of the Integrated Experiments Division, you were responsible for the development of experimental satellites and payloads. You talked about that a little bit already. Can you describe some of the projects your team worked on? Were there any projects that didn't go as planned, and what did you learn from them?
Yeah, no, that's a. I'm glad you asked that question. That's a great question. The group there in Albuquerque did a lot of hardware development in assembly, integration, and test. AINT is called, of spacecraft in house in high bays and clean rooms that are there in Kirtland, um, which I think is incredibly valuable, to the rest of the, at the time, Air Force and the Space Force now, that we have people, government employees and contractors and military members inside of a clean room wrenching on satellites. That gave us some hands-on credibility that we know what we're doing, and it's part of the in-depth knowledge that the institution as a whole needs to have. If we just relied on government contracts and prime integrators to build all of our satellites, we would lose our edge in terms of knowing what really goes into developing a satellite. And so that was largely what that operation was and still is about, is assembling and integrating spacecraft. And we have learned lots of lessons. So I mentioned this Angels spacecraft that was integrated and assembled in a high bay in Albuquerque. And all the ground testing, software testing, we had lots of people doing great work there. All eventually we got to the point. There's an old joke in space flight that when the weight of the paperwork equals the weight of the satellite, you're about ready to launch. Well, we had got to that point, and we launched it and had a successful launch, and it started flying. This would have been in 2014. We were doing some of the launch and early orbit checkout procedures just to make sure that the thing was doing what it was supposed to do and behaving before we started doing the experiment. And make a long story short, all of a sudden we lost contact with the satellite, just went silent. And that was a disaster. That was not only because I was the mission director of that satellite. Um, the fact that we had lost it just represented, several $100 million worth of taxpayers' investment that just went silent. And I was just imagining in my mind testifying before Congress what went wrong, what was the problem here. Uh, And we had teams working on doing anomaly resolutions. We would send commands up to the satellite. We'd hear nothing back. And now you don't know, did the satellite hear it or not? And if it heard it, it might have taken action, and that would put it in a different state than if it didn't hear it. And every time you send up a new command, you created a bigger tree of possible states that the satellite could be in. And so you had to be very careful about what you did. There's a whole art to these anomaly resolutions. Well, eventually, I believe it was about a week later, somebody discovered that there was probably a bit flip on the satellite, that it still thought it was in the fairing on the launch pad, that it hadn't launched yet. And there was a bit that was set in that condition not to turn on the transmitter, because that could, if you transmit inside of the fairing, you could cause all kinds of damage to the other sensitive microelectronics. And somehow that bit had gotten turned on. So we sent up a command to turn off that bit, and all of a sudden we're back communicating with it, lots of sighs of relief. But that was a good lesson learned about, not only the simplest things can cause major problems, but the rigorousness of your software testing on the ground before you send something up, to make sure there aren't any of those stray bits laying around in the code, is very important.
Yeah, that's I guess part of the benefit of being risk averse.
Right. Right.
Yeah. You worked at the Air Force Research Laboratory Geophysics Directorate for 9 years. What were some of the most significant research initiatives you were involved with during that time?
Yeah, and that was sort of my first job out of graduate school, was working for Air Force Geophysics Lab. And as I sort of alluded to earlier, my PhD is in physics, but with a particular interest in atmospheric physics, terrestrial physics. And when I started at the geophysics lab up in Boston, it was sort of the end of this period, but there were lots of great discoveries going on in that lab about the nature of the atmosphere, including the stratosphere and low Earth orbit. They published a big thick book called the Handbook of Geophysics every few years that had all the latest data and information about that domain. So it was a pretty exciting place to work. We were kind of coming to the end of that. From that time, the field of terrestrial weather has really become a big commercial entity. The government's still involved in collecting data, but a lot of the forecasts and products that you get are big business. It's people producing that. So the need for a research lab in the government to do that work kind of started diminishing, and that's when I got into the space physics world. But it's one thing that I tell young folks who are considering a life in civil service like I had 35 years of the greatest time, the ability to participate in just big scale science and technology development. It's been amazing. Like I mentioned, these satellites that the Angel satellite was launched on my birthday in 2014. So I was the mission director. So I always said that was my birthday present. I had my own satellite that I was flying around. Don't tell anybody that, but that's how I explained it to my mother anyway. Believe me. So that was great. And same in the Air Force Geophysics Laboratory. We were doing some fundamental research on things like atmospheric lightning, icing conditions for aircraft, the space physics stuff that I've already talked about. So, the life of a government scientist can be pretty darn exciting, I think, because you get to be involved in pretty big things. And the amount of authority and control over those things that you can have is often quite high. So it's a pretty fun place to work. And I encourage people that are young and thinking about getting into a science career to to look at the government. It's not as bad as everybody seems to depict it. It's actually a pretty great place with some security to it to work.
Okay. Let me get into my, I guess you'd say, 3 or 4 closing questions. What are some of the most pressing scientific questions that you believe space exploration can help us answer?
Well, so I think today the real concern is what resources await us in space. So today we're making great developments in things like quantum computers and clean energy, but some of those, electric vehicles, for example, depend on certain rare earth materials that are hard to find. If we don't find ways to produce those, it's going to be a limiter in some of those technology areas. For example, think about fusion energy. One of the thoughts that's been propagated for many years is that the abundance of helium-3 on the moon could be valuable for, if you could get it back to Earth, valuable for clean fusion energy. Other resources and the ability to manufacture new medicines and biological materials, artificial tissues in orbit in the microgravity environment is pretty exciting. The potential is exciting to do that. So there's sort of practical outshoots of space exploration. All of that stuff was enabled by originally our ability to go to the moon in the first place, but returning there and exploring ways to benefit from the resources and the capabilities, the vacuum of space, the microgravity of space, the resources that could be found there are paying dividends now, or we're on the precipice of paying dividends now. So I think the further we go, the better. I think we need to maintain our ambition. So we need to keep doing our exploratory mission to the moon, to the Mars, and beyond the solar system, because it's that kind of what I call high-end thinking that drives the discovery of new capabilities that can actually help us here on Earth.
Mm-hmm. Okay. And what are your greatest worries and hopes for the future of space exploration?
Well, my greatest worry is that that this future of warfare in space grows out of control. That we don't find ways to deter aggression in space and to maintain peaceful uses of space. I think that would be horrible to have space dominated by anti-satellite weapons and maneuvering and those kind of things. So that's not the future we want. So we want to avoid that. The most encouraging thing that I see today is the development of commercial space. It's with reusable launch, drawing the cost of putting mass into orbit to lower and lower levels. It just opens up the possibility of the things that we could do. And I think we're only just scratching the surface right now. I don't think we've fully appreciated, if you can really get 150 metric tons of material into space at just a few $100s per metric ton or per kilogram, then once you imagine all the things that could be done, I think we're going to see amazing things happen. And then that's not even to mention the Elon Musk's goal of getting to Mars and beyond. I think we're just going to see some pretty fantastic technological and application development in the coming years.
Mm-hmm. And my last question, if members of the audience want to learn more about your work or connect with you, what is the best way for them to do that?
Probably LinkedIn would be my the most easy way to get a hold of me. So I have a profile on LinkedIn and always happy to chat.
And what is what's your full name on LinkedIn? Does it use your middle initial?
Joel B. Mozer should find me.
Okay.
Yep.
Excellent. Well, thank you, Doctor, for taking the time for this interview. It's great stuff.
Thank you. Appreciate it very much.
That was Dr. Joel Mozer. This has been From Here to the Stars, a video series created by the Interstellar Research Group. The IRG is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. Join us October 12 to 15, 2025 in Austin, Texas for the Interstellar Research Group's 9th Interstellar Symposium. Learn more at irg.space. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please hit the like button, and you can subscribe to our channel for other such videos. On behalf of all of us here at the Interstellar Research Group, I thank you.